infinite limits. Here we want to discuss what happens to a function when you evaluate it when x approaches c, that the limit ends up being either negative infinity or positive infinity. The definition of this is defined here, for example, the statement that f is a function defined at every real value in some open interval containing c, except possibly at c itself. The statement, the limit of f of x as x approaches c is equal to infinity, means that for each capital M positive, just say short abbreviation cap M positive, there exists a delta positive such that f of x is greater than cap M whenever 0 is less than the absolute value of x minus c, less than delta. And here it says see the figure right on the side. Then similarly, the same thing happens for negative infinity. Now, what does all that means? What this means is that for each capital M that you can find positive, there exists a number delta that puts a bound on x. In other words, it's possible that when you find the restriction for x to be in the neighborhood of c, and as x gets close and close to c, what is delta? Delta is infinitesimally small. Delta is so small that it almost looks like 0. That as you get close and close to c for the x values, the y values either explode into positive infinity or they explode into the abyss. Okay? And so here, for the first part, there exists a delta for some cap M positive such that the function value is always bigger than that capital M whenever the x values get very close to c. This is saying you can always find a function value bigger than M. You give me some M based on delta, and you can find a function value bigger than that. You can shrink delta, and basically you get like a reciprocal effect. When you shrink delta and the x values get close and close to c, the y values, they exponentially get larger and larger. And so here we have a limit of infinity. Now, what we have described, my friends, is something that you've seen in pre-calculus algebra, and that is the vertical isotope. That the vertical isotope is exactly what I just got through explaining. I sound like one of my old professors at the university. That's funny. So, definition of a vertical isotope, and I do hate to labor on this and to make it more difficult than what it is, because a vertical isotope is a vertical isotope, right? You find the so-called vertical isotopes for a rational function when those x values, when the denominator is set to be 0. And so the definition, to try to get rigorous here, if f of x approaches infinity or negative infinity as x approaches c from the right or the left, then the line x equal to c is said to be the vertical isotope. Again, the vertical isotope is given from a rational function, correct? I think we can just go right to it and look at some problems. So the vertical isotope, and if you recall from algebra, it's the same thing. To find the vertical isotope, you set the denominator equal to 0, solve for x. I just use abbreviation. Vertical isotope is VA. Here, x is equal to 0. And I think in web assign that they may want you to capitalize x. I think this is the one. No, here's what it wants. You just can't write 0. You have to type in x equal to 0. I don't like red. Red, red. His name is Red, Red, Red. He's going to be dead. Anyway, the vertical isotope here, if you set x minus 3 equal to 0, you get x equal to 3. And this is, it's not difficult. For this denominator, we have two values for the vertical isotope, x equal to 2, x equal to negative 2. Here, x squared plus 9 is not equal to 0 for any x in the real number system. Indeed, you get plus or minus 3i for x, but they're imaginary. Therefore, no vertical isotope. Ooh. Okay, do a little factoring. So h of x is equal to x minus 3 times x plus 3. This is all over. Factor downstairs. Looks like we can pull out x squared first. We have left x plus 3 there. Then over here we pull out a negative 1 times x plus 3. So h of x is equal to x minus 3 times x plus 3. And it's all over x plus 3 times x squared minus 1. The x plus 3 will cancel out. Notice you can factor again. So we get x minus 3 all over x minus 1 times x plus 1. So the vertical isotopes we have here is x equal to 1 and x equal to negative 1. Okay, just want to make sure sometimes I can write and leave something off and drive myself crazy. All right. Look at this next one. We can factor the top and the bottom. The top is t times t minus 2. Then the bottom is t squared minus 4 times t squared plus 4. We can't factor the t squared plus 4, but we can factor the t squared minus 4. So we get t times t minus 2 all over t minus 2 t plus 2 times t squared plus 4. You can divide out the, cancel out the t minus 2. And from there you can see that there's only one vertical isotope, negative 2. So now we want to find the limits here. They will be limits of infinity because we are evaluating the limit about a number that x approaches to, whereby when you plug that in, we get something that's indeterminate. So, I told you before, you either factor, you rationalize, and thirdly, you use L'Hopital's rule. Here, I suppose we can add a fourth one on there, graph. Boy, that just came to me. I just ate a chocolate chip cookie, and so I got some inspiration. And they put this here because they want you to go back to when you dealt with rational functions and you graph those back in pre-calculus algebra. And then from there, you can take that very same problem and trace the limit. You were actually doing it unaware. Isn't that good? So the vertical isotope here, well, this right? So the vertical isotope, do you see it, is x equals to -1, right? If you remember the basic graph, that is for y equal to 1 over x, the basic graph is this. And so this graph here for number 33 just takes the basic graph and just shifts it over by 1 because x moves over to -1. So we'll just do that. We say x is -1 here. That's the vertical isotope. And we get the graph. You recall from your pre-calculus algebra that the horizontal isotope would be y equal to 0. And do you recall how to find that? You look at the power of the denominator, excuse me, the power of the numerator, and you look at the power of the denominator. If the power of the numerator is less than the power of the denominator, then the horizontal isotope is equal to 0. Well, the power appears x to the 0, 0 power. It's x to the first power. So 0 less than 1, so the horizontal isotope is y equal to 0. If the power of the numerator is equal to the power of your denominator, then you take the two leading coefficients and you divide, you get a ratio. That's your horizontal isotope. And if the power of the numerator is bigger than the power of the denominator, then you have either no horizontal isotope or some kind of oblique isotope, but it will not be horizontal. Okay. So anyway, that's a good talk, but okay, we don't care about that. What happens when x approaches -1? Remember, this is 0, this is -1. As x approaches -1, here it says from the right, plus sign from the right. It goes up to space, to upper outer space, if that makes sense. Okay. So anyway, it goes to positive infinity. See that? Plus infinity. Down here is negative infinity. As x approaches 1, from the right, positive infinity. So I'm just going to say plus infinity here for the answer. Okay. See if I can do something. It won't let me do it. Okay. Now, the vertical isotope is x equal to 1. X minus 1 equal to 0, x equal to 1. This function is always negative because this is -1 divided by something positive, so it is always negative. So we find here x equal to 1. And since it's always negative, and it hovers with respect to the isotopes, again, the numerator's power is 0, the denominator's power is 2, 0 is less than 2, so the horizontal isotope is y equal to 0. So as x approaches 1 from the left, we go down to negative infinity. And the same thing happens when x approaches 1 from the right. It still goes to negative infinity. So you write here negative infinity. Now, when it's x divided by x minus 2, it does not look like 1 over x for the basic graph. So this is called an improper fraction. Anytime we have an improper fraction, we want to divide. Improper fraction meaning that the numerator is, the degree of the numerator is equal to or greater than the degree of the denominator. Here our power upstairs is 1 and our power downstairs is 1. So they have equal powers for the top and the bottom, so we have to divide. So we divide x minus 2 into x. X goes into x, 1 times x times x. X times 1 is x. And then negative 2 times 1 is negative 2. We draw a line, subtract, that becomes negative, that becomes positive. And x minus x cancels out, we bring down the 2. So we say this is equal to the limit as x approaches 2 from the right, and this is 1 plus 2 over x minus 2. Right? We just turn this down 1 time, right? So this goes this away, that goes that away, that goes that away. Just turn it 1 time, and so we have 1 plus 2 over x minus 2. So we put it there. All right, now that's cool. The vertical isotope is, you could have gotten that from back here, is 2, right? The horizontal isotope is 1. So the horizontal isotope is 1. The vertical isotope, let's see, this is x-axis, y-axis. The vertical isotope is 2. Horizontal isotope is 1. Why did it move? Mercy. Good. Scary stuff. And what this guy will do will just basically shift the basic graph up 1 and over to the right 2. So now the question is, what happens with this particular graph as x approaches 2? I don't know why I did that, but anyway, what happens to this graph as x approaches 2 from the right? So this is x equal to 2. As x approaches 2 from the right, this guy goes to positive infinity. Okay. What happens as x approaches 2 from the left? That would be negative infinity. I believe we can factor the limit as x approaches negative 3 from the left. And again, if you plug in x equal negative 3, you're going to get 0 over 0. So it's an indeterminate form. So we're going to factor x plus 3 all over x plus 3 times x minus 2. That x plus 3 is cancel. So we have the limit as x approaches negative 3 from the left of 1 over x minus 2. Well, here we have removed the discontinuity. Just plug in x equal to negative 3. So that'll give you 1 over negative 3 minus 2. We get negative 1 over 5. Okay. So we have here a removable discontinuity, and we evaluate the limit as such. We removed it by the cancellation. Now consider the limit of 1 plus 1 over x as x approaches 0 from the left. The horizontal asymptote is 1. The vertical isotope is x equal to 0. So the horizontal isotope is y equal to 1. The vertical isotope x equals 0, or the y-axis. So this is the graph. So as x approaches 0 from the left, this goes downstairs into the abyss, and that's negative infinity. Is there anything else? I think that's it. Okay? So if you have any questions, just get in contact with me. Thank you.